In this question, there is a plane that is flying at 75 meters per second, and there's a target that is 250 meters below it. And we want to know how far does the plane need to be from the target in order to successfully drop the package exactly where the target is. Now this is a projectile motion question, which means it has an x component and a y component. The x component is uniform motion, so the acceleration is 0. And since the object is initially moving with the plane, it has a velocity of 75 meters per second in the x component. Now the y component is free fall motion, which means the acceleration will be negative 9.8 meters per second squared. The initial position of the package is 250 meters, and the final position of the package will be 0 meters because it will land on the ground. And we also know the package's initial velocity in the y component, so VIY is equal to 0 meters per second. And I know that because all of the velocity is initially in the x component. Now we are solving for delta x, which is the distance between the plane and the target. To solve for delta x, we need to use the uniform motion equation, which says Vx is equal to delta x divided by delta t. And we can rearrange this to isolate for delta x. Now we have Vx. What we're missing is delta t. And what we're going to do is use the y component to find delta t. To solve for delta t, we need to use the yf is equal to yi plus viy delta t plus 1/2 ay delta t squared kinematic equation. We will plug in our values and rearrange for delta t. And what we find is delta t is equal to about 7.1 seconds. Now that we have delta t, we can use our uniform motion equation, rearrange it for delta x, plug in our values, and we find that delta x is equal to about 533 meters. That means the plane needs to drop the package 533 meters before the target so that it will land exactly where the target is. And that's the end of this projectile motion question.